Okay, we are recording. So here we go. Remember, the test is going to give you a lot of quadratic equations, but it's going to tell you how you have to solve them. It's not enough just to get the right answer. You have to do it the way they tell you to do it. So you could put these in the quadratic formula, okay, and give me the right answer, but I can't give you the points. These want the square root property. Everybody see that? So we're going to have to use the square root property. Okay, so remember, if it's square root property, what do you think we're going to have to do? Square root, right? That's what we're going to have to do. Okay, so what we want to do is isolate the square term. We want x squared all by itself. So I'm going to add 3 to both sides, and I'm going to get 2x squared equals 128. Okay? Then I'm going to divide both sides by 2. Whoops, that doesn't get crossed out. Okay. And I get x squared equals 64. Okay, now remember, a lot of students, they'll know you take the square root, they want to tell me the answer is 8. But how many answers should you have? 2. So my answer is not just going to be 8. It's plus or minus 8. When you take the square root of a squared letter, over here on the right, you better have a plus and a minus. And then the square root of 64 is 8. So that should be your answer. You have to be really careful and don't forget that, okay? All right, let's try the next one. Okay, same thing, but we just want to practice. So square root property, we're going to subtract 10. We get x squared equals negative 16. Take the square root. It's going to give us a plus or minus on the right. Now we have a negative under that radical. Have little I, and square root of 16 is 4. Make sure you know when it's going to be an I and when it's not, and that's just because it's negative, right? That you have the 2. Stop. Oh, you're squeaking? Yeah, I know. I don't know. Your dad will probably come up with something to do with fix that. Okay, so those are those 2. So square root property, that's what we're dealing with. All right, next thing we're going to have to deal with, I know I didn't give you a lot of room. I'm sorry, I'm going to put another paper on there. We want to solve this using the quadratic formula. Okay, remember, you guys are going to have to remember the quadratic formula. So if you don't know it already, write it on a piece of paper or a Post-it or an index card. Put it on your bathroom mirror. Put it next to your bed. Put it in your car, sticking it on your dash. Put it everywhere you are so that you constantly see it and you can say it while you're getting ready, while you're driving, whatever it is you're doing, just put it in a lot of places so that you can constantly remember it. Let's see if we can remember it. Okay, I'm going to put this down so I have a little bit more room. So you have the song. Miss Holcomb doesn't sing, so I'm not singing. Remember, we also have that little story where we said the very negative boy couldn't decide if he wanted to go to the radical party, but he was a square. He didn't go. And he missed out on 4 amazing chicks. I mean, if nothing else, maybe the 4 amazing chicks will help you figure out what goes under there. And then what time's the party over? The whole thing, even this part, the whole thing is over when? 2 a.m. Okay? So try to remember that if all else fails, but put it everywhere you're going to be throughout your life until Tuesday so that you can see it. Okay, so let's see. Number 5, I'm going to leave it here just so I have more room. But number 5 is x squared equals 2x plus 4. I'm not so sure about this camera. It keeps going in and out. They're probably going to freak out. Okay, so we need to move everybody to one side. So we're going to have x squared minus 2x minus 4. We need everybody over there so that we can name our letters. Okay, what's our A? 1. Our B, negative 2. And our C is negative 4. There we go. Everybody good with that? Okay, now we're just going to plug them in. So this tells me negative b, or the opposite of b. But my b is already negative 2. So what am I going to put here? Yeah, or you could do negative with the parenthesis negative 2, but when all comes down to it, it's just going to be 2, right? A positive 2. Because this says negative b or opposite of b, but my b is already there, negative, so I just put a 2. Plus or minus. Okay, what's negative 2 squared? 4, because it's negative 2 times negative 2, that's a positive 4, minus 4 times 1 times negative 4. Okay, and it's all over 2 times 1. Okay, here we go. We're going to have 2 plus or minus. All right, let's figure out what goes under here. We're going to have a 4. Okay, I'm going to have minus a negative. So am I going to be subtracting or adding? Adding. Because minus a negative is adding. I just went ahead and handled that. Then I've got 4 times 1 times 4 is 16. And that's going to be a square root of 20 under there. Okay. Everybody okay with that so far? Okay. All right. Can I go, oh my gosh, look, I could divide everybody by 2. No. Yeah, you can't go in here. All right, but I can reduce it. So remember, 20 breaks down. No matter how you break him down, you should end up with 2 2s and a 5, right? No matter what you do. Then these come out. Who's left under? 5. Now we have ourselves a triangle. And I can divide every point by 2. And I'm going to end up with 1 plus or minus root of 5. And there's my answer. Okay? Is everybody okay with how we did that? All right, make sure you practice that. Now, there is another quadratic formula problem. It's number 6. You could practice that one all by yourself. The answer's in the back. I'm going to post this study guide on content as soon as you leave. And I'm going to send you, well, I'm not going to do it on the video, but I'm going to post this. So if you want to practice number 6, you should practice number 6, right? And make sure that you're comfortable with it. Does that make sense? Okay, but it's the same thing. And the answers are in the back. Okay, let's move that. Okay, next thing we're going to do is 7. Okay, we're going to do 7 and 8. It's the same problem, but I just thought it wouldn't hurt us to practice. Okay? All right. Now it wants you to solve this for 7 and 8 by completing the square. Okay, we're going to complete the square. So if we're going to complete the square, we have to take the constant, the one that doesn't have the x, and move it to the other side. Then we're going to need to leave a blank on each side because we're going to add something to it. So we're going to have x squared minus 12x. Now we've already subtracted the 27 to the other side, but I'm going to leave a little blank here on each side because I'm going to have to add something to each side. Does that make sense? So all I did was subtract this over. Okay, now we have to figure out what is going to go in the blank. Okay, so it's going to be b divided by 2 squared. That's what goes in the blank. So remember, you know how to identify a, b, and c. What's my b in this case? A negative 12. Okay, so I'm going to put negative 12 divided by 2 squared. Okay, let's work this through then. Negative 12 divided by 2 is negative 6. When I square negative 6, I get 36. It's always going to be a positive number because you're squaring it, always. So that's what's going to go in each side. Is everybody okay with that? That's your completing the square. You did it. Okay, now what you've created over here on the left is a PST, a perfect square trinomial. So we're going to do 1 parenthesis with a square. We're going to take the square root of the first term. Oh, gracious, this pencil. Okay. The sine of the middle term and the square root of the last term. That's how we got that. square root, sine, square root. And then when I add those together, let's see, what do I get? I get a 9. Okay. Now you're really done with completing the square. Now where you're picking up is the square root property because you want to get that square off. So you're kind of back to the square root property. We're going to take the square root of both sides. Okay. Now remember, everything's going to come off the left beautifully. But there was a letter over there. And when you take the square root of a squared letter, what's going on the right? Plus and minus. You have two answers. And square root of 9 is 3. Okay. Now we're going to add the 6 over, but it's not enough to add the 6 and circle it. You're going to actually have to find the two answers. So you're going to have x minus 6 equals the positive 3. And x minus 6 equals the negative 3. And then when you add 6 to both, here you get a 9. And here you get a 3. And those are your answers. Okay. Is everybody okay with that? That was weird. It's a lot. That's why I thought we might want to do 2. Okay. How did we know that I needed to split this up and keep going? Because those were both normal numbers, right? There wasn't a square root, there wasn't an I, there wasn't something that prevented them from combining. So that's why I knew they had to both go together. Okay, let's try it again. It's always easier when you try it again. Okay, so again, if I'm completing the square, I have to move this guy. Now I'm going to leave room. I'm going to add 1 to the other side, but then I'm going to leave a little blank on each side because I'm going to have to put something in it. Okay, so we want to do b divided by 2 squared. So what's my b in this case? 20. Okay, so I'm going to take 20 divided by 2 squared. He's going to be big, but there we go. So 20 divided by 2 is 10. 10 squared is 100. If you need to, put that in your calculator. Okay. All right, now we have ourselves a PST. Okay, so let's remember how to fill the parentheses. We do square root, sign in the middle, square root of the last. What's the square root of 100? It's 10. You just squared that. Okay, and then over here on the right is 101. Okay. Everybody okay on that? All right, now we're going to take the square root of both sides, right? Everybody on the left is just sitting pretty, beautiful, okay? Now remember, I have to have a plus or minus, and then square root of 101. Can I do anything with that? I can't. There's really nothing. You can try to break it down. It's prime. It doesn't, there's nothing you can do, so he's there. Okay, now, I'm not solved. I still have to subtract this 10. Now, when I up here, when I added the 6, I went ahead and split them up because I knew these were going to combine. Do I need to split this up? Do you think the 10 and the square root of 101 are going to combine? They're not, because if there's a radical or an I, they can't combine. So I'm just going to subtract 10. It's always kind of good math manners to do that in front of a radical. And that's my answer. But if you wanted to put minus 10 on the back, that's perfectly fine. I'll take that if you don't want to put it in the front. And that's your answer. Okay? Is that all right? Okay. That's it for this page. Okay, so you're just going to have one of those, but practice it so you remember what to do. All right, you're only going to have to deal with complex numbers in one way. So it's going to be division. So if you flip your page over, notice 11 and 12 are both division, right? Yours is going to look like 12. Okay, yours is going to look like 12 because look at the difference in 11 and 12. There's an I in the top of 12. So that's why yours is going to look like that. So if you want to practice number 3, you certainly, number 11, you certainly can. But 12 is the one that you're going to have, okay? Because it has the I in the top. This one doesn't, so it's a little easier. Okay, so let's practice 12. It's going to say to divide. All right, So how do I divide? Well, I can't have an I in the bottom. I'm going to have to multiply the top and the bottom by something. Complex conjugate. What's the complex conjugate going to be? 3 plus 2i. Remember, all you're doing is changing the sign. You got to multiply the top and the bottom. We don't care what the numerator is. Now, I know we're not doing 11, but just so we can practice, if I was, what would I multiply top and bottom by for this guy? 4 minus I, because all you're doing is changing the sign. So he would get 4 minus I. This guy's going to get 3 plus 2i. Okay, you know I like parentheses. I don't like to leave anybody out. Okay. All right, so 12, we're just going to distribute. I'm sorry, I'm at the top. I don't know what's wrong with me. Okay, 6i times 3 is 18i. And then 6i times 2i is plus 12i squared. Negative 12. Good, Joy. We're going to come back and do him in a minute. But yeah, immediately you should know that. Okay, let's try the bottom. We're going to FOIL. 3 times 3 is 9. 3 times 2i is 6i. Negative 2 times 3 is negative 6i. Good, the conjugate's working. Remember, the whole reason for this is we get rid of i's. And sure enough, that's going to cancel. And then last but not least, negative 2i times 2i is minus 4i squared. So that's going to have to be handled too. We have a lot of cleanup. Okay, so let's work on the top first. All right, 18i is fine. Okay, so remember, I squared is negative 1. So 12 times a negative 1, what's going to be sitting here next to 18i? A negative 12 or minus 12. And remember, I always, anytime I see I squared, I get rid of it and I change the sign on the term. So it's kind of another way to do it really quickly. Okay, down here in the bottom, these two are going to cancel. And I'm going to have 9. What's this minus 4i squared going to be? Plus 4, right? Because it's a negative 4 times a negative 1. Or you could get rid of the I squared and change your sign. Okay, we still have some work to do. Okay, first of all, let's look at the numerator. I need it in this form, a plus bi. I'm not in that form. I need the I in the back. So even though I can't really do anything with this, I need to rearrange it. I need it to be negative 12 plus 18i. Okay? And then in the bottom, I have a 13. Can I reduce this in any way? No. Now, I'm perfectly fine taking this, but on your final exam, when you have this problem, because we know the crazy calculus lady, it's going to be like this. It's going to be separated. So this really is the most correct answer. Yeah, and in my math lab, it separates it because, again, a plus bi, it's 2 separate terms, but I'm fine if you want to leave it like this, as long as it can't be reduced, as long as there's no triangle, okay? All right, now we want to solve by grouping. Everybody okay with that? All right, you have 2 grouping problems, so you can certainly practice 13 and 14, but yours is going to look more like 13, okay? All right, so why does it look like 13? Because you're going to have stuff on each side. And students think they can just jump right in and start doing their parentheses and pulling out, GCFs and go to town. Can I do that? No, you have got to move everybody over. So that's why yours is going to look like that, because I want you to take the extra step and scoot everybody over. All right. Other than that, you can practice both of these if you want to. Okay, now we're ready to group. So solving by grouping means you put in 2 groups of parentheses. There you go. Okay. Now we want the GCF of each one. So what's the GCF of my first parenthesis? X squared. So I can come in here and divide both of the terms by x squared, and I'm going to get x plus 2. Okay, perfect. Now I go to my next group. All right, I see a minus, so I know I'm going to have to pull a minus out. What else do I need to pull out? A 9. Okay, be careful here. I'm going to divide each term by negative 9. It's going to give me a positive x and a positive 2. Watch your signs. This is also your checkpoint. At this point, these better be exactly the same. If they're not, you missed a sign or did something wrong. Okay, now I'm going to pull one of those out. It's kind of like the GCF. I divide it out. What's left? X squared minus 9. All right, and I was just about to say, do you think we're done? But Alexis mumbled it through his mask. Look at this guy. We can't be done if we have a square. We're not completely done. So this little guy is a difference of squares. Okay? All right, there's nothing I can do with x plus 2, so he stays. But this little guy is a difference of squares. So I'm going to have opposite signs, square root of x squared in the front, and square root of 9 in the back. And I should have known I was going to have 3 answers because look at my exponent. It's a 3. So I should have known I would have 3. Now I have to keep going because this is going to say solve. I'm not done. So this is going to give me x equals negative 2. This guy is going to be negative 3. This guy is going to be 3. And there's your 3 answers. Okay. All righty. Well, so you certainly practice 14 if you want to. Okay. The answer's in the back. You're going to see this completed study guide on content. This would normally be when we would practice our graphing calculator problem, but we don't have to. Okay. So we're going to keep going. Did I turn that too soon? Is everybody okay? Okay. All right, let's look at nope, I lied. What are we looking at? 15, thank you. 15. Okay. 15, we have little fraction problem. We're actually going to do every problem on this page. Okay, so all it tells you to do here is solve. That's all you got to do is solve this guy. Well, you and I both know we don't want fractions because they make our life difficult. So here's a little packet in the bottom of this guy. Here's a little packet in the bottom of this guy. We're going to need to get an LCD. We need to factor him. Who do you think he factors into? Yeah, these other two that are right here. That's who he's going to factor into. Now you can still do that to make sure that's right. Put in your x's. You're looking for factors of -6. So one's positive, one's negative, that add together to give you a positive 1. Sure enough, it's, yeah, a +3 and a -2, or -2 and +3. It's exactly these parentheses. Yours is going to be the same way. So this is going to factor into the other 2 denominators. Okay, so our LCD is just going to be these 2 packets. That's what it's going to be. Does that make sense? Because, 90% of your problems, math problems, end up factoring into the other denominators. Okay, now we need to multiply every top. Okay, every top, because there's an equal sign, by those guys. Every top gets multiplied. Now you're going to have some stuff cancel out. So if we look at the first term, the x plus 3 packet cancels out, and I'm left with a 5 times the x minus 2 packet. So I'm going to have to distribute that in a little bit. You could do it right away if you want. It's up to you. There's my plus. Okay, x minus 2 packet cancels out. I'm left with a 1, well, that's not important, times x plus 3. If you want to leave him in the packet, you certainly can. You don't have to. Maybe I'll just do it like this for now, just so you know where it all came from. It's up to you. And then over here, everybody cancels out, and all you're left with is the 5. Ta-da. Okay, everybody good? All right, now let's clean it up. So we're going to distribute this and get 5x minus 10. Okay, you can distribute the 1 if you want, but really you have x plus 3 equals 5. Okay, we're going to combine 5x plus 1x. We get a 6x. Negative 10 plus 3, negative 7. We're going to add 7. We get 6x equals 12. We divide by 6. And that big old complicated thing was a little 2. I don't know if that makes you mad or makes you happy, but the answer is 2. Okay. All right. Now let's look at 16 and 17. Everyone okay with the fractional one? Okay. These two, you're only going to have one of these, depending on which version of the test you get. Okay? These are the weird things. So don't expect a nice answer. The answer to one of them is no solution. The answer to the other one is all real numbers. Okay, so we're going to do both so you know exactly what that looks like. But you're going to have one of those on your test. Okay, you're not going to know it. They both look like normal problems, right? But when you go to solve it, you're going to end up with one of those answers. So let's try 16 first. Nothing to do on the left yet. He's just 7x plus 5. I'm going to distribute the 5 over here in a plus 2x. I'm going to combine these like terms on the right. Okay, from that point, some of you can already see what this is going to end up being. But next step would be subtract your letter term. Let's combine the letter terms. So no matter which one you try to combine, when you subtract 7x, what happens to both of them? They cancel. So you have 5 equals 15. Well, does 5 equal 15? Are those the same numbers? No. So what's the answer to 16? No solution. No solution. Remember, you can also do the little Ghostbusters thing if you want. It's up to you. No solution. Okay, good. So that's how we know. The letters cancel. You have two numbers that are not the same. All right, let's look at 17 and see if we know what that one's going to look like. Okay, so again, we're copying over the left. We're going to distribute the 2 on the right. We still have a plus 3x plus 23, though. Okay, let's clean it up. 4x plus 3x is 7x. Negative 10 plus 23, 13. Some of you already know what that one's going to be. Okay, if you keep going and you try to combine your letter terms, they cancel, and you're left with 13 equals 13. Does 13 equal 13? Yeah. So I don't have any letters. What am I going to call this? All real numbers. I'm going to just be lazy and put AR in. You're certainly welcome to. You can make the double lines with the big R, same thing. Or if you just love to write, you can write out, I don't know if that's how you spell infinitely, but I'm going to pretend it is, many solutions. Any of those will work, whatever you want to do, okay? So notice the difference. That's how you know, but you'll have one of those. All right, are we ready for 18? Okay, I'm going to scoot it up. Okay, 18 has a radical in it. All right, we need to get it by itself. Remember, any funky term you encounter, get it by itself. So I'm going to add x. My stomach's growling. I hope that's not on the video. Okay, there we go. All right. So how do you think we want to get a square root off? Square it. We'll just square both sides. Okay, the left side's going to be beautiful. 2x plus 13. Okay, why did Alexis say gross? What does this mean? There's 2 of them. We have to foil. We have to foil. You have to actually move your little hands and do work. Okay, so x times x is x squared. And we have a plus 5x, another plus 5x, and a plus 25. Okay, slide this under here. Okay, so if we clean this up, 2x plus 13 equals x squared plus 10x plus 25. Okay, now what do you think we need to do with these guys on the left? We need to move them. We need to move them over and make a nice little quadratic, okay, to solve. So who does 2x subtract from? the 10x, right? That's his people. Minus 13 is going to subtract from the 25. I'm going to get x squared plus 8x plus 12. All right. Now, you got to solve this. You're going to get two answers. You can put it in the quadratic formula, but this is going to factor really beautifully. Okay? So I would factor if I were you. He doesn't have a GCF. He's a monic. All right, let's think of factors of 12. Now, there are quite a few. A positive 12. So they're both going to be positive or both negative. And they're going to add together to give you 8. 6 and 2 will do it. Okay. We're going to solve for this. We get x is negative 6 and x is negative 2. Now, we are not done. Don't flip yet. I know. Unfortunately, you need to make a note that with a radical equation, I don't know if you remember, it makes an extraneous solution. These are not going to both work. Only one answer is going to work. And so you're going to have to check it. This is the only problem where that happens, but it's going to happen. So you're going to have to check both. Okay? So you're going to have to come over here. Let's check negative 6 first. A lot of you can just do this in your head, but it's always a good idea to just make sure we're comfortable doing this. So we're going to go back to the original, and everywhere you see an x, put in a negative 6. So I'm going to have 2 times negative 6 plus 13 under the radical minus a negative 6. It's going to be a plus 6 equals 5. Okay. Under the radical, I'm going to get negative 12 plus 13 plus 6 equals 5. Under the radical, I'm going to get a 1. Okay. What's the square root of 1? 1. So that says 7 equals 5. Does that one work? No. So in that case, this guy does not work. Then it's going to have to be the other one because one of them is going to work for you. So if you want to plug that negative 2 back in and check, let's just do it in our heads just to save us some time. So negative 2 times 2 is negative 4 plus 13, 9. Square root of 9, 3, minus a negative 2 would be plus 2, which is 5, which does equal 5. Okay, so I would encourage you to work that out and do it, but just kind of for the sake of time, I just wanted to show you that that's only one of them are going to work. So make a note on your paper. Only one works on the radical one. Okay. Okay, so that brings us to 19 on the next page. Is everybody okay on that? Okay. All right, 19 has a rational exponent. It has that little 2/3 up there. So remember, anytime you get something funky, you have to do the opposite action to get the funky off. So if it's squared, you take the square root. If you got a square root, you square it. If you have that little fractional exponent, you're going to raise it to the reciprocal. You're going to flip it and raise both sides to the flip. Okay, that's what you're going to do. Is it okay if I move this? Yeah? Okay. Okay, so let's raise both sides to that reciprocal because we want to get the 2/3 off. Okay, so I'm going to raise both sides to 3/2 because, oh, you can't even see that, but okay, the reciprocal of 2/3 would be 3/2. So I'm raising both sides to 3/2. That's what I'm doing. Does that make sense? He was 2/3. I just flipped him. Okay. This is going to come out to just be x minus 3. Perfectly. Okay. All right. Now it's this other side we have to think about. So let's remember what a 3/2 means. 3/2 means you have an exponent of 3 and you have an index of 2. So you're cubing him and then you're taking the square root. What happens when I take the square root of a letter that's been squared? You get plus or minus on the other side. You're going to get 2 answers on him. Okay? You're going to get plus and minus. All right. Now, you can do this by hand, but you can also use your calculator. It doesn't have to be the fancy calculator. It can just be the regular old whatever calculator. They all do it. I can take 9. There's your little caret. You might have y to the x instead. Parenthesis, 3 divided by 2, close your parenthesis, and you get a 27. Okay, you should get a nice little neat number. Make sure you can do that on your calculator. It'll work no matter which one you have. If you don't have the caret, you should have the y to the x, but you're going to need to put parentheses in. Okay, and then you'll get 27. Another way you could do it is just take 9 cubed and then take the square root of that, and you still get the 27. But 9 raised to the 2/3, whoops, 9 raised to the 3/2 is 27. Okay, that's all you got to do. All right, now can I combine both of these? Yeah, I'm going to add 3. So I need 2 different equations to do that. I'm going to have x minus 3 equals positive 27, and x minus 3 equals negative 27, since I can combine these. So when I add 3, I'm going to get x is 30. And when I add 3, I'm going to get x is negative 24. Okay? And you get 2 answers. I know this test is a lot. It seems like there's a little trick on every single problem. This test is a lot to remember. This is not like your other tests in college algebra. This is like a final exam for intermediate algebra. It's a lot, I know. So just try to stay with it and remember what you got to do, and it'll get better. Huh? What?
I thought we would do x minus 3 plus 3.
No, because either way, you're going to add it. The adding 3 doesn't change. It's this guy that changes because he has the plus and minus. Yep. Remember, the plus minus always goes on the right side of whatever when you get the funky off. Okay, let's look at 20 and 21. You're going to have each one of these on your test, and it's an absolute value problem. You're going to have both. 21 is not meant to trick you. 21 is meant to be easy, but it tricks some people, and I don't want it to trick you. So let's go back to 20 for a second, though. Okay, absolute value, we want to get that little guy all by himself. So we want to add 6. Okay, and we want to divide by 2. So that we have the absolute value part and it equals 8. Okay, now is when we're going to have to split up again, because remember, the absolute value of a negative or a positive is a positive. So we have to have 2 parts of these because we don't know what's actually in there, and we're solving for x. So we have to split them. So you're going to have 1, whoops, I'm sorry, you can get rid of the bars at this point. We're going to have 1 equaling 8. And we're going to have 1 that equals what? Does anybody remember? Negative 8. Okay, don't change what's inside the bars. Leave this alone. Change what's on the outside. Okay, now we're going to add 3 to both sides, and we get x is 11, and x is negative 5. Okay, you have both. You don't really need to check these other than to check yourself to make sure you're right. That's always a good idea. I shouldn't discourage you from doing that. But both answers are going to work, except on the radical one. Okay. All right. Why do I say that this is supposed to be easy? Well, let's start to isolate him. Okay. If I start to isolate him before I split him up, look what I end up with. Can the absolute value of anything be a negative? No. So what's the answer to number 21? No solution. So it's meant to be an easy one. As soon as you realize that the bars equal the negative, you can stop. Okay? Is everybody okay with that? And you're done with that one.
We can have a negative.
Can't have it, yeah, because the absolute value of anything, even a negative, is still positive. So you just stop. If you want to keep going, you can. And then when you check both your answers, neither one of them work. Okay, let's see. Let's go on real quick to 26 and 28 because that's required on the test, and we're going to come back to the bonus. Okay, but let's do 26 and 28 while we're on a roll. Okay, everybody okay with this? Okay. All right, let's do our inequalities real quick. Okay, so I don't have it listed on here, but you may want to make a note that you're going to have to do three things. You're going to have to solve them, graph them on a number line, and write them in interval notation. You're going to get points for each one. Okay, so three things you're going to have to do for 26 and 28. You don't have anything like 27. Okay, here we go. 26, plain old, regular little compound inequality. I want x by itself in the middle. So I'm going to subtract 3 from everybody. Okay, I'm going to get 4 and a 2x and a 6. Okay, everybody good on that? Okay, I'm going to divide by 2. And I'm going to get 2 and an x and a 3. And I'm done. Easy enough. Okay, so that's one part. All right, now I have to graph it. So here's my number line. Okay. There's my 2 and my 3. Remember, with these compound inequalities like this, they face each other. They make a cage, right? All you have to figure out, is it going to be a parenthesis or a hard bracket or a mix? So what's the 2 going to get? A parenthesis, because he doesn't have the line under it. What's the 3 going to get? The bracket, because he has the line under it. There's your little graph. Okay? Interval notation is super easy. You're just going to copy that. And then you're done. That's all 3 parts. Okay? Everybody okay? So compound inequality, they face each other. You just have to decide what they have. Okay? Yes, and if it doesn't, I'm going to say it a million times and write it on the board. And you'll be in here and I'll go, psst. Yeah. All right. Okay, let's come down here and look at 28. Look at the difference in 28 and 26. There's an absolute value. Absolute value means you have to do some other stuff, right? It's a little different. Okay, before we know what we have for absolute value, because it depends if it's less than or greater than, we have to isolate. Okay, we have to isolate. And then, what happens when I divide by that -4? We got to flip it. It's a greater than 3. Okay, when your absolute value inequality is a greater than, how many are you going to have? 1 or 2? 2. Remember how to remember that? 2 is greater than 1, right? So the less than has 1, but you don't have one of those. You're going to have one that flips into a greater than. You're going to have 2 separate inequalities. Everybody got that? You need to write that on there. Remember, 2 separate inequalities. So here we go. We're going to have one that looks exactly like what we just wrote with no bars. Okay. Then you're going to have another one with the same left side, but then we're going to make 2 changes. Do you remember what they are? We're going to flip our inequality sign, and we're going to make our number negative. Okay, I know it's so many details. I know, just keep studying. There's a lot of extra study guides you can grab before you go. Okay, so 2 separate. Now we're going to solve them like normal. So I'm going to subtract 2. Oh my gosh, my x is negative. So then I have to divide by a negative. What happens to my sign again? Flips again. So you're going to end up with x is less than -1. Okay, I'm going to subtract 2. Divide by a negative. Going to end up with x is greater than 5. Okay. All right, now you still have to graph and you still have to do interval notation. Now you can put both of these on the same number line if you want to, or you can make two separate number lines. It doesn't matter to me. That is your choice. If you decide to do just one, keep in mind, this is not a compound inequality. They're not going to face each other and make a cage. In fact, they're going to be completely separate from each other. So here's my -1. Here's my 5. Okay. This says x is less than, with this little arrow, -1. Is he going to be a parenthesis or a hard bracket? And he's going to face the door. He's going to face that little bracket. Okay. Over here, still a parenthesis, but his little arrowhead looks like this little arrowhead, so he's going to face the window. And there we go. Now, the only wonky part, really, now we have to do interval notation. So remember, you have two separate intervals. You're going to have a union symbol. So here we go. We're going to have, let's stick this down here. Okay. You're going to have negative infinity. Infinities get parentheses. To -1, he has a parenthesis. 5, he has a parenthesis to infinity. Okay, because it's this and it's this. Right? It's this little guy and this little guy. What do we put in the middle? The union, the big fat bottom U that says this one and this one. You need both. So that's kind of tricky. You guys aren't used to something like that. I'm sorry it's so low. I was trying to kind of keep it all together. Okay. Now we have the bonus. Is everybody okay with this? That one's tricky. Yeah. So number 23 is your bonus question. Okay, it's 5 bonus points. It's a substitution. It's going to tell you to solve by substitution. All right. Make sure everyone's got this. A couple people still writing, so I want to make sure you get it all. Okay. All right. Okay, so number 23. Remember, you're not able to solve that, so you're going to have to substitute. And we substitute y for the middle variable term. That's what we're going to do. We're going to substitute y for the middle variable term. Okay. Here we go. 23. Okay, so I'm going to substitute y equals for this little letter. Not the 7 also, just the variable term. That's it. Now remember, we said if we square both sides, y squared is going to end up being this term, right? We said that's going to happen. So what we're doing is we're rewriting this as y squared minus 7y plus 10 equals 0. That's all we're doing. We're just rewriting it. And it's because of this one substitution. And then if you square both sides, you get that y squared equals this. Everybody good on that? Okay, that's the kind of big leap of faith. Now, we have a nice little mnemonic to factor. So we need factors of 10, either both positive or both negative, and they need to add together to -7. Good, both negative. How about a -2 and a -5? Okay, that would multiply to +10. That would add to -7. Okay, we're going to solve now. Y is going to be a 2, and y is going to be a 5. Okay, now we're not done. We can't circle it and be finished because the original problem has a bunch of x's. Now we're going to have to remember this substitution. So y equals 2, but y also equals x to the -1. So I'm going to come down here and put this back in. You've got to remember to make that substitution once you have used everything you need to do. Okay? All right. Now, what does x to the -1 mean? 1 over x, right? Just means you're going to move it to the denominator across that fraction bar to make it positive. It's like x to the +1. You just move it down. That's why this one's a bonus, because it's tricky. It's a lot of stuff to remember. Okay, we can't leave it like this. So remember, there's that little quick and dirty switcheroo. Does everybody remember that? Where what would x equal for this guy? 1/2. And what would x equal for this guy? 1/5. You're just changing places with the x and the 2. 1/2 and 1/5 are your answers. But if we want to be really mathy, let's see why. Our LCD is x. So if we multiply both sides by x, x's cancel. I get 1 equals 2x. I divide both sides by 2. And sure enough, x equals 1/2. But look what you could have switched. So you could do the same thing here. Okay. Multiplying both by the x. Whoops. You get 1 equals 5x. Divide both sides by 5, and you get 1/5 equals x. And those are your answers. Okay? So that is